Hello, everybody. Thank you very much for joining us. It's this evening here in Camas. I know it's in the morning for many of you. Doesn't look like my video is showing, but it doesn't matter. This is Susie Truitt, and it's nice that all of you were able to attend this distributor training for the 751 Avocado quality meter. This instrument has been extremely well received. We just recently attended the World Avocado Congress in Colombia about a week and a half ago, and were quite honestly overwhelmed with the reception, the number of orders that we received, and the number of leads that we had for people from all around the world interested in this instrument. But what that also did was inform us that there's some information that we wanted you as our distributors to have, so that you can go out in the field and talk to these potential customers and answer their questions, and so that you have a better understanding of how the instrument itself works. Maria says, I'm not hearing. Can all of you hear me? If you want to use the chat box, you can either just say yes or no. Okay. It may be just a technical problem with you, Maria. You'll have to check the speakers on, I'll type Maria a message, because if she's not hearing me, she doesn't know. Okay, she is hearing me now. Excellent. So anyway, thank you again for all of you for coming to this. We'll keep this short, but we'll also have a Q&A session at the end of the presentation. And so any questions that you have, if you would use the Q&A box, that way we can keep track of them rather than putting them in the chat box. So with that, I'm going to turn the microphone over to Galen George, who's one of our application scientists, and he'll start the presentation.
Awesome. Thank you, Susie. Like Susie said, thanks everyone for joining us. I hope that this training session will be very informative for you all. Before we get started, I want to quickly go over some housekeeping stuff and also some introductions. You all know Susie, or if you don't, you really should, because she's our distributor manager. She's kind of been probably your point of contact with us. And so before we get going into the actual content of this, just some housekeeping stuff. For your questions, please use the Q&A function, not to be confused with the chat box. So do not use the chat box for any questions you're having. But if you are experiencing technical difficulties, like lack of sound or video, please feel free to put that in the chat box. But for all questions that you want answered at the end of the session, we can, it'd be great if you could just put those in the Q&A box, and I've delineated where those are in that image there. And then also, whenever you see links, you won't be able to click them, obviously, on the PowerPoint itself. So Susie will be posting relevant links and extra information that we might need. She'll post that in the chat for you guys. So a little bit about myself. If you haven't met me before, as Susie said, my name is Galen. I am an application scientist here. I have my bachelor's degree in biochemistry and a master's in food science. I am an IFT certified food scientist, and previously I worked in the analytical field as a manager of an analytical food laboratory, and also as a food safety consultant. So I kind of have brought my knowledge of the analytical testing world to Felix Instruments. And so I'm always here as a source if you guys need to reach out with questions regarding our instruments, regarding any sort of processes involved with our instruments. You can always reach out to me. We also have another application scientist on staff here. His name's Eric. And Eric is also kind of from the analytical side of things. And so he's also a very good resource, and he's also heading our support team. So he is a great resource for anytime there is malfunctions with instruments or things of that nature. So both of us are all resources, as well as Susie. We're all here to help you guys. So whenever you have questions, please feel free to reach out to us. So today we're talking about the 751 avocado quality meter. Now, we've had a webinar about it already, but this is kind of more geared towards best practices, tips and tricks, and other considerations when using the instruments, so that you guys have more knowledge, so that when customers come to you with issues or with questions, hopefully you'll have some more resources now to be able to answer those questions. So we'll start off, we already did the introductions, but we'll kind of briefly go through the overview, which is going to be very similar to the overview from the webinar that we gave on the instrument when we launched it. But then we'll go into the applications and the specifications, kind of review that. And then the real, I guess, kind of meat of the webinar is going to be talking about best practices, our calibration protocols, and stuff like that. Help you guys kind of understand all the different ways that a measurement can be influenced, how to compensate for biases and stuff like that. And then, like Susie said, we'll end with the Q&A session. So just an overview. We created this instrument to kind of tackle the problem of the length of time it takes to do destructive lab analysis to measure your avocado quality, as well as to provide a tool for people out in the field, and to be used for harvest applications. Just a general way to assess avocado quality without having to actually destroy the sample. So what our instrument does is that actually measures dry matter using near-infrared spectroscopy. And the reason dry matter is so important for the avocado maturity is because it correlates really well with the oil content. So oil content is really the actual quality parameter that is of the most importance, but dry matter, because it has such a strong correlation to oil content and it's way easier to measure, that's what the instrument itself does. And so with the launch of this product, it's a new way to go about assessing your avocado quality without having to do the laborious, time-consuming, destructive laboratory analysis. As I mentioned, applications of the F-751 can range from harvest management, harvest timing, predicting when when is best time to actually perform your harvest. Post-harvest applications like quality management in storage rooms and ripening rooms, and also quality assurance applications like spot checking for quality in your distribution facility or in a packing facility, or even at the retail outlet. And then a final potential application that we've had a lot of interest in is in the research field with university and government agencies, research agencies that are interested in post-harvest and breeding and things of that nature. So the instrument itself has a lot of potential to be used in not just in the fields for harvest, but in other areas as well. As far as who's using it currently, so Mission Produce is a big customer. They utilize it right now in a quality aspect, and then they're also planning on implementing it in harvest. Dr. Kerry Walsh was actually one of our biggest collaborators, and he helped us create this the model. He's helped us develop the technology. He's been with us pretty much the whole way through. And Dr. Jorge Asuna is also he's been a very instrumental player in creating the model that we have, and also in testing and creating new models, not just for avocado but for mango as well. So a brief overview of how it works. This might be review knowledge for some, it might be new knowledge for others, but essentially what we're doing with the instrument is we are measuring the interactance of light inside of the fruit flesh itself. So basically the instrument will shoot light into the fruit. The light will interact with the molecules inside of the flesh, including water and carbohydrates and all the other macronutrients and micronutrients. And that light then is reflected back. Well, not necessarily reflected, but when the molecules go back to the ground state, they release the photons, and then that is all that data is captured by the detector within the instrument. And what is called a spectra. And so the spectra is really the raw data that this instrument collects. And what we do is we correlate the spectra back to the model that we have built, and that then can predict a dry matter value based off of the spectra. And that's the value that shows up on the screen. So a lot of calculations kind of happening in the background from the actual data that's collected in the instrument. Some features of the instrument are that it is GPS enabled, it is Wi-Fi enabled, it's very user friendly. So these 751 models are meant to be an instrument that can be used by anyone, because it's just really a tool that you can turn on, press a button, and you get a measurement. There's no extra steps involved. The measurements take under 12 seconds. You know, it's a portable, durable device that's ready to use right when you take it out of the box. It's got the transflective display, so it's great for outdoor viewing. It's kind of like a Amazon Kindle, where if you have a light, it's not going to be glaring on the screen. And we also all instruments utilize rechargeable batteries. So if the instrument runs out of batteries, all you have to do is put in a fresh new pair of the rechargeable batteries that are charged, as opposed to having to plug the instrument in itself and then having to wait for the instrument to charge. So that's a nice benefit for when you have a long day in the field. You can always just carry an extra set of batteries on you. Specifications of the instrument, our spectral range is 640 to 1050 nanometers. The data that this records, the raw data, reflectance data, absorbance, first and second derivative, and also the GPS state, coordinates, date, and time. The battery life, it can last 500 plus measurements, and it's like I said, durable, heavy-duty powder-coated aluminum body. Weighs a little over a kilogram. If you want to access information that's even more in depth than this slide, feel free to check out the link that's posted in the chat. That's on this PowerPoint. That's just on our website. There is a tab under the F-751 Avocado quality meter that says specifications, and you can see all the specifications there. You can also always see them in the manual for any technical questions that a customer might have. So let's get into the stuff that isn't review necessarily here. What we're going to talk about first is factors that can affect measurement variance. So there's really three sources of variance when it comes to utilizing this instrument to get a predicted dry matter value. There's variation within the fruit itself. So it's not a homogeneous fruit. There's dry matter is going to vary. There's variation due to the analytical procedure that is used to get your reference values. And then there's also variation due to the instrument. So variation due to the instrument is something that we can obviously provide you more information with. I'm going to also talk about variation within the Avocado in the coming slide here. And the variation in the analytical procedure is something that comes into play if you're using inferior technology in your laboratory, if you're using a balance that only goes to 1 decimal place, if you're using a refractometer that has an uncertainty of plus or minus 3 degrees Brix. These are all factors that only compound the error that can be present within a model. But the variation within the avocado can be mitigated, as well as the variation due to the instrument. So that's something I want to talk about a little more in depth here. So this is something that I highly recommend all of you read this paper that I've put a link here of. This paper is kind of a review of basically a study on measuring avocado maturity, but it has a really good graphics, has really good information on how dry matter can vary within the avocado itself. So when you look at an avocado, the dry matter can vary up to 15% depending on where you take your sample from. And if this is in an analytical sense, so say we were just going to go dehydrate an avocado. If we took a sample from, say, the inside near the pit, or where the neck is, but closest to the pit, versus a piece of flesh that was really, really close to the skin, near the bottom of the fruit, you can have, as you can see from these two images that were from that paper, a 45.2% dry matter on the outside, on the bottom of the fruit, versus 13.2% dry matter, at the inside neck near the pit. So it's really important to be consistent and scan in a place on the avocado that's going to give you kind of an average reading of what the dry matter is throughout that fruit. And the place to get that average dry matter is not in the neck, and it's not in the bottom of the fruit. It's at the equator of the fruit. So we've come up with this little infographic here on the bottom left of the screen that kind of shows where you should scan on your avocado. So this is what we recommend is on the dorsal side, which is the side that has the larger bump near the stem. So if you look at an avocado, I don't know if you can see this very well, but there is the stems right here, and then this side is the ventral side, and then this side with the larger hump after the stem, that's the dorsal side. So scanning on the dorsal side equator would look something like this. So that's where you're going to get the most representative measurement of your avocado, because the light's going to penetrate, and it's going to penetrate deep enough that it's going to get a good representation of that entire average of that dry matter within the equator there, which is kind of the middle ground between the neck and the bottom of the fruit. So that's something that's really important to talk to your client or your customers about, when they're going to go implement these tools, is that they need to be consistent where they measure, but also they should be measuring at the equator of the avocado to get the most representative result. So then the other side of that, it's important to mitigate your error on the, where you scan on the fruit side of things. But then, how does the instrument itself create error? So, I'm sure a lot of you have had customers, or, hopefully not a lot, but I'm sure some of you have had customers that say, if I scan twice in the same spot of an avocado, I'm getting two different results. Well, that's what's going to happen, because our models are not completely infallible. They're not 100% accurate. That's quite literally almost impossible to achieve without having millions upon millions of data points in our model. So what we do when we create models is we make sure before we release it that the instrument can provide accuracy within 5% of the measured value 95% of the time. So, for example, this table on the top left shows if you take 5 measurements and they are ranging between, it looks like 19.2 and 21. The analytical value was measured at 20. that means that at 20% dry matter, our instrument was designed and the model was designed to read within 19 to 21% dry matter, because that is within 5% of the dry matter value, of the analytical dry matter value. So because when we did these 5 measurements, all of them were in between 21 and 19, this model is performing well. And actually, as you can see, even though your first 2 measurements seem like they were so far different, if you average them out, you're going to have a value that's really close to the analytical value. So that comes to another point of, if you want to increase your accuracy, you can scan more than once. And actually that will provide you with an even stronger confidence in the number that you get. So if you scan, say you want to scan on both, or you want to take 2 scans from the dorsal side equator for each avocado, and then you take that average, it's going to be likely a more accurate value than a single scan, because the more scans you take, the higher your accuracy is going to be. The bottom graph here just explains what I already explained, is that 95% of all of our measurements, so in a normal distribution, that's 2 standard deviations from the mean or from the true value. 95% of every scan you take is going to be within 5% accuracy of the true value. So if it's 10% dry matter, if that's what the avocado truly is, then 95% of the time you're going to get a value between 9.5 and 10.5. So that's just kind of an explanation of how we go about ensuring that our instrument is performing as accurately as we want it to be. However, that's not the be all end all. We don't stop and say, oh, the model's performing, to that specification, and that's it. We're not gonna work on it anymore. We continuously strive to improve the models and the instruments themselves, so that we can get even tighter than within plus or minus 5%. So that's just an explanation as to how we try to mitigate error on the instrument side of things, is that we don't release these models. We don't give out instruments or models to our customers that aren't performing within that specification. However, there is something that has come up in the past. I'm sure it'll come up again in the future. There is a procedure that we do before we send out all of our instruments, and we call it a calibration. And essentially what we do is we set an offset bias, which essentially makes sure that if the instrument is reading, it's still reading within that 5% specification, but all of the results are consistently 2% low, or they're all consistently 3% high. We can actually fix that doing this calibration procedure and creating an offset bias, because every instrument is unique in the sense that not all the electronics are going to be exactly the same. No matter we order them to be the same, but it's literally impossible to ensure that everything within this instrument is exactly the same as every other instrument we make. So we perform this calibration protocol, and this is actually a tool that customers can use, because despite the fact that we do it in-house, this offset bias can be influenced by things like your environment that you're in, the type of avocados you're using, the stage of maturity of the avocados that you're measuring, and all sorts of other external factors can influence this offset bias. So say, for example, we do the calibration here like we normally do. but we're using avocados that are from California. And then we send a unit to Mexico or South America or Central America, and they're taking all their measurements, and it's in a really harsher environment, and it's hotter, and they're using a different. They're trying to measure shepherd avocados or any sort of factor like that. It actually would be beneficial for these people that are seeing that kind of a trend where, like, hey, why are all of my results, all of my predicted values are, X percent low or Y percent high. This procedure that I'm going to show you is actually something that they can do themselves, or you can do with them or show them how to do, to actually then create their own bias. And by doing that with their own fruit, that's just going to make the instrument that much more accurate to their specific fruit. So this is a useful procedure that not everyone needs, but some people, some customers will need this calibration to be done. So how it works is essentially what you're going to do is perform several scans of avocados, followed by performing the analytical measurement, and then you're going to compare the two, and you will calculate the offset based on the difference between the analytical values and the predicted values. And then once you update that bias in the instrument, it will then be reading what the closer to what the analytical values should be consistently. So the initial step is to what we do is we gather 5 avocados, and we want them to be as a representative sample of your fruit that you're going to be testing on a regular basis as possible. And you're going to label them 1 through 5, and we use a silver Sharpie, but you could also use a white Sharpie. We don't use black because it's just harder to see generally on the avocado. But any sort of marking, permanent marking device that will be visible on the fruit is acceptable. Once you've labeled them 1 through 5, you take essentially 4 scans from each avocado that are going to be equidistant from one another along the equator. So you won't just scan the dorsal side. Let me turn this the correct way. There we go. So you won't just be scanning the dorsal side. You'll basically take a scan. You'll mark where that scan is, where you took that scan from. You'll turn it 90 degrees, take another scan, mark it on your avocado, turn it another 90 degrees, take a scan, and then one final time, 90 degrees, mark it, take another scan. So at the end of the scanning a single avocado, you should have 4 distinct areas equidistant from each other along the equator, and each time you should make sure you mark it with what we do is we label it with the letter A, B, C, or D. So you have essentially created so you have avocado 1, and then you have scan A, and then avocado 1 scan B, and so on and so forth. Once you've done those scans, what you want to do is prepare to start the actual analytical testing side of things. So what you would do is you would label 20 small empty weigh boats, because you're going to have 5 fruit with 4 scans each. So that's 20 total samples. And what you'll do is just label these 20 small weigh boats, 1A, 1B, 1C, 1D, all the way through 5A, 5B, 5C, 5D. And you'll want to weigh each one of those boats and record that value. And what I should have mentioned before I even started talking about this is that we have created a spreadsheet that has the protocol directions for this entire protocol, as well as pictures and all the calculations necessary. So it's a really simple plug in your values and it'll spit out your results kind of worksheet. And we will be making that available to you guys, so that if you need to perform this with a customer, then you can have that tool to be able to just type in your numbers, get your value, and then I will demonstrate to you how to update that bias in the instrument. But I'm getting ahead of myself a little bit here. So once you've labeled your empty and weighed and recorded your empty weigh boats, you will then begin the fresh weight determination. And so this is a pretty important step because you need to perform it quickly. The fruit is going to naturally lose moisture once you've cut it open. So you need to work quickly, but you also need to work accurately, and you don't want to be sloppy, basically, when you perform this. So what you would do is, as you can see in the picture here, you're going to cut the avocado in half so that you have 2 scan sites per half. And then what we use is this coring tool. With this coring tool, and we don't send it out with our instruments because this is not a procedure that we expect people to have to do. But however, since this is something that has been that we have had to perform, we will be sending these out to you guys, to the distributors, anytime that there's an order for a 751 Avo, just so that you have that tool in case you do need to perform this calibration procedure. So anyways, you've cut avocado number 1 in half. You have 2 scan sites per half. You've removed the pit. What you're going to do is you're going to use this coring tool, and you're going to take a core that's approximately 2.5 to 3 centimeters wide from your scan site A. You're going to pull out that core, and then with the tool, you can see the picture to the right of the first picture with the coring tool. The second coring tool picture, you'll see that you can essentially push out part of that core, and you're going to cut off all that excess pulp that was closest to the pit, and then you're going to remove that core slice, and it should be around a centimeter deep. A little less is fine. You don't want it to be too thick though, because then it won't be able to fully dry when you go to dry it. And what you're going to do then is also discard the skin of the fruit as well. So you cut it where that red line has shown you there. You want to keep the pulp that was close to the skin and also near the middle of the avocado, and then discard the pulp that was closest to the pit and the pulp that are in the skin of the fruit of that cored sample. Once you've done that, you're going to place that sample into the weigh boat that's labeled 1A, because that's where you took the core sample from, and then you're going to record that weight. So that is your fresh weight plus the boat weight. And then after that, what you're going to do is repeat that entire process for every single course, every single scan site, and also every single avocado. So you would start with avocado 1, cut it in half, you core the site A, weigh it, core site B, weigh it, core the site C, weigh it, core site D, weigh it. Move on to avocado number 2, cut avocado number 2 in half, and so on until you've finished collecting all your fresh weights for all the scan sites. Once you have that, then it's time to just make sure you dry the avocado. We recommend either using a food dehydrator. You definitely don't want to hydrate it. A food dehydrator set at around 135 degrees Fahrenheit, and you want to leave it for at least 48 hours. I recommend even letting it go to 72 hours, but you do want to check it every day. And you want to check your temperature because you want to make sure nothing's burning. So even though you're letting it sit that long, you still want to check it periodically. But also what we've transitioned to, our technology that we've transitioned to, is using the microwave method. We actually have a microwave analyzer that does all the weighing and everything for you. But even if you wanted to use a standard, household microwave appliance, as long as you have a standardized procedure that is capable of removing all the moisture without burning any of the avocado, That's what's important. So follow your standardized procedure. The dehydrator is a pretty tried and true, method. Oven drying is also, very tried and true. Microwave's kind of newer, but can make things go faster. But like I said, it's kind of up to the customer what they traditionally have done in the past. I kind of say stick to what you've done, unless you can observe that what they're doing is not effective and they're not drying it enough, or they're they're burning their samples. So after it's dried, after the 48 to 72 hours, what you want to do is, if there are burned samples, just remove those from the analysis completely. Do not incorporate those, because that will influence your final results, your final offset bias, and you don't want it to do that. So remove anything burned, and then weigh the boats that have the dried cord samples in them. So that will be your dry weight. And then once you have that, you can then utilize the worksheet that we've prepared. And what it'll do is you'll calculate the average difference between the predicted values and the analytical values. And then that value will be input into the instrument through a series of steps that I can show you. They're also in that series of keystrokes is in the worksheet that I'm going to show you. But I will also demonstrate it live for you so that you can see how to go about putting in that value into the instrument itself. But then once you do that, then it's ready to go, and it should be tailored more perfectly to the customer's specific fruit. But like I said, this isn't something that should be necessary 100% of the time. It's more of a something that we can do to alleviate an issue with a bias present when a customer has extenuating circumstances with working in a harsh environment or something like that could influence the data. So let me pull up the worksheet for you guys really quick to show you. Let me find the share button. There we go. To show you what it's like. There we go. So the same pictures that were in the PowerPoint are there. What we have here is 4 tabs that kind of that go in the order of how the test needs to go. So the first one is for this tab kind of goes over the scanning process. The next tab goes over how when you're collecting your analytical dry matter. The next tab is there is no data input here. It's just kind of a visual to help in like a series of questions to help ensure that that you're proceeding properly. And then the last tab, intercept update, actually will give you what your correction bias is for you to input in the instrument. And it also gives the instructions, as I said, to actually go on the instrument and perform these keystrokes to actually input that value. So let's go back to the beginning here. And so it lays out everything that I just said to you, went over with the calibration. It's a completely locked spreadsheet except for where you need to input data. So you won't be able to edit things like this, like the sample number or the instructions. It'll say it's protected sheet. But the prediction values delineated by this blue arrow are where you need to input data. So you just go through and you pull the data off the instrument itself, and you write down in these cells what the predicted values were. Then you go over to your analytical tab. Once you have all of your data for your analytical test, you input that here into these cells. So you have your initial empty boat weight, the boat with the fresh core, and the boat with the dry core. And this will spit out in this column is a calculation for what your analytical dry matter value is. The next tab will pull both the data from the first tab and the second tab. So you have your predicted and analytical tabs. So you don't have to input these. These will automatically get pulled over. And what it'll do is over in the in this average section, is show the average dry matter prediction and the average analytical value, and then it'll calculate the difference between those. And over here, this cell will be green if this answer to this question is yes, which is essentially asking if your bias is more than 4% dry matter. If it is more or less, or if your difference is plus or minus 4 or greater, then you should contact us at the support email or contact us directly, because that might indicate that there's an issue beyond a bias. And then this will show the R-squared value for the regression that this plots. So what this plot down here is showing is all of your predicted versus your analytical dry matter values. And this data set, when you plot a regression line through it, should be parallel or close to parallel to this line that is drawn already on the graph. When that line is parallel, that means, but if it's parallel and not touching, that means that there's a bias that's present. If you notice that the slope of your dotted, plotted blue line here is significantly different than the slope of this black line, then that means that there's something else going on, and it might be that the model hasn't been updated. The instrument is using an older model or something like that. So again, this cell will turn green. This R-squared cell will turn green when the answer to this question is yes. But if the question is no, again, contact us so we can try to troubleshoot the problem further. So this tab here doesn't actually require any input of any kind. It's just kind of a check to see, is this something that we're going to be able to easily fix right here by just putting in this offset bias, or is it a greater issue that we need to contact us, support, or one of the application scientists directly. So as you can see with this data set that we're using, the R-squared is good. It's 0.99. It's fairly parallel to the solid line. The difference is only 0.72. So if you go to the intercept update tab, you will actually see that there's a spot to input data. So since, like I said, we calibrate these all before we send them out, every instrument should have a prediction intercept value already in the device. And so what you would do, say our intercept that we had already put in there was -2. What this will do is update this so that you have your new prediction value to put in. Once you have this, where the star is at this grayed out cell, this is the new value that you're going to need to input into the instrument. And now let me show you exactly how to do that, because every instrument, when it first shows up to the customer, is going to be in a menu mode called simple. So let me just get, I just need to click stop share. Great. Okay. So there we go. So I just turned this on, and you'll notice that when you click the right arrow, you have the normal menu for an F-751. This doesn't allow you to actually do anything with the model. All you can do is browse measurements, upload, or change your default lot. So what you need to do is you need to go down to setup, click the right arrow, go all the way down to factory setup, click the right arrow again. It'll prompt you for a passcode. The passcode is really hard to guess, but it's just 1, 1, 1, 1. And to change these values, you just click up and down arrows to change your integers there. And then once you've input 4 ones, you click the right arrow again. One more time, it'll say processing, and now you have access to more advanced features. So what you would do is you click down and see how there's an option that says menu mode. Click right. Simple is the menu mode that all of these instruments come like standard. They're on simple menu mode, so that the clients, all they have to do is press the measure button. There's no advanced features available to them. But in order to change the offset bias, you need to actually change it to standard menu mode. So you just go up, click the right arrow, it'll switch it, and it'll bring you back to the home screen. So where the simple menu mode has the upload to fruit maps and all those options, this now gives you an option for a select model. So what you're going to do is you want to click right arrow on select model. That's the only model on here, the Avocado. So you click right again. And then what you're going to go do is advanced options. So you go over to advanced options, and then you'll see an option that says prediction correction intercepts. And that is the bias that I was talking about. And what you'll do is you'll select it for dry matter. And you see this one already has 4.5 built in. When you update and that whatever the new value of the sheet is, you'll just change this number with your up and down arrows. And then once you've changed it to what you need it to be, you click right all the way. It'll save it. And then what you'll want to do is return this back to simple mode. So all you have to do for that is you click the left arrow till you get back to the main tree again. And you go down to setup instrument, right arrow. You go all the way down to the second screen. You go to factory setup. You go to menu mode. And you go down to simple. You click right arrow. And then you're back to simple mode. So now it's ready to go. And it's got the new bias intercept in there. So the clients should be able to take it from there and have much more accurate readings. So that is our calibration procedure, and all that information is going to be available for you. It, like I said, shouldn't be necessary, but sometimes it might be. So something that we thought that you guys should know about. So let's get back to the PowerPoint here. Let me find my slide that I was on. There we go. So put it on slideshow mode. There we go. Fruit maps. I'm not going to go into a demo for fruit maps yet because I did it on the last we did it for mango, we did it for avocado, but just want to update you on the progress with fruit maps. Fruit maps has now been switched to new servers, and so it is up and running more smoothly than ever. So it is available for all customers to upload their data to. We are currently we have an engineer working on updating the programming, the software, actual code of it, so that it grabs data from the nearest weather station and other cool improvements like that to actually increase the accuracy of the prediction feature of the harvest map in fruit maps. So really cool stuff coming soon. When that does come out, we will have a full webinar on fruit maps itself. So be on the lookout for that release. But for now, it's still the same fruit maps that it has been. It's just now more reliable because it's on new servers, and it is accessible to everyone that has a 751 or a 750 now. So yeah, so that's most of what I wanted to cover, just in summary. You know, the instrument you know about, it's a dry matter instrument. You can get your results in less than 12 seconds. It's you know, a way more simplified way of obtaining those quality parameters, as opposed to doing the classical laboratory analysis. There's a wide range of applications. You can use it, you know, in harvest and in quality assurance settings, and post-harvest research, breeding programs, phenotyping, things like any really. There's a million applications out there for it. And then the really important message of today's webinar for you guys is, you know, for the best results, you need to scan at the equator on the dorsal side. Taking multiple scans is always going to increase the accuracy of the instrument. And the calibration process, although we do it here before we always send out instruments, sometimes it's necessary, but it's a pretty simple process. And I think with the worksheet, it makes it even more simple, pretty foolproof. And it's something that you can do with your customer to ensure that their instrument is working for their fruit as best as it can be. So yeah, this is just a plug for some stuff we have coming up. I'm currently working on the Kiwi model for our new F-751 Kiwi quality meter. That should be out before the end of the year. That'll measure both dry matter and bricks. And then we also, really exciting, have a new and improved leaf spectrometer for our CID side of things. So that's going to be a really cool tool to see out in the hands of researchers. So, like I said, if you have any questions, contact us. Anything support-wise, you can send. If it's a direct support question, you can email the support email. You can also directly contact me or Eric or Susie. This is all of our other contact information, all of our social media accounts. If you follow us, you'll be able to stay more updated on what we're doing and where we're at in the world. And then we have some really cool upcoming webinars coming up. So on Tuesday, this upcoming Tuesday, October 15th, we will be hosting a webinar on the F-750 and all the applications that it can be used for, talking about people that are using it in new and innovative ways, talk about some use cases. We'll talk briefly about model building and determining trait viability and things of that nature. And then in November, beginning of November, we will actually have a model building webinar where we will go through the entire process of model building. And our lead engineer for the 750s, Brian, will be on the question and answer session for that. He's a very, very well educated on chemometrics and things of that nature. So those are really cool webinars. I would highly recommend any customers that you have that are interested in the 750 and post-harvest or phenotyping or breeding research. Definitely let them know about this webinar because it's going to be really informative, I think. So, like I said, email our support, call us, whatever. If you have questions, I'm always happy to help. And I guess now I will answer some questions for you guys. If you have questions for me in the Q&A, looks like I got some.
I'm going to just chime in here real quick. Here, Galen. Over in the chat box, if anybody, if you hadn't noticed, I put the links to register for the webinar next week on 750 applications. We just sent out an invitation to that to our list of 15,000 people. But if you have customers who would be interested in attending those webinars, absolutely share those links with them as well, because that webinar is for customers, for prospective customers, and for distributors alike.
Awesome. Yeah, it's going to be, those webinars are going to be very, very cool. So our first question is there a difference in accuracy depending on the temperature conditions? That's a great question. So there is, and so what we recommend, so our model is built using a temperature correction factor that we've come up with that ensures that the instrument model will read accurately in the field as well as in the lab. If you do plan on using this in like a like cold storage facility, if your avocados are going to be really cold, that will influence the model and how it predicts. So we always recommend, especially for the calibration procedure, that you use room temperature avocados. But like I said, we do have a built-in temperature correction into the model, so that it is still accurate within the range of the uses that we intended it for. So harvest, and in the use in the lab. So there is a difference in accuracy, but that's typically only for colder applications as opposed to the hotter. So yeah, that's the answer to that question. Will the kiwi also work on gold zespri? Yes, it will. So I was just in Italy working on validating the model with, and actually mostly on gold. The model at this point, we're leaning towards what we're probably going to do is build in a basically a decision in the model where it will read the spectra in the visible region to see whether it is a gold or a green kiwi. And then from there, it'll apply the model for the gold, or it'll apply the model for the green, because they do predict differently. So you can't necessarily have them both in one model. We tried to make one model for both varieties, but it's just not working as well as two separate models. So what we're thinking we're going to have is that built-in kind of logic where it'll see in the spectra in the visible range that oh, this flesh is gold, oh, this flesh is green, and then from there it'll know which model to apply to it. So yeah, it will be for both gold zespri and Hayward green. Yeah, it looks like
that's all the questions that we had, unless anybody else has a question, and you're welcome to type that into the Q&A box. I will take this moment to let you know, I just put up in the chat box the link to the Felix Distributor Resource website, and on that website is the Excel spreadsheet for the calibration procedure that Galen went over, as well as a PDF of the slide explaining how the accuracy of the instrument works. So that's something that you can share with your customers so that they can understand how that 1% or the 5% accuracy works. So those two things are now up and posted on the Felix Distributor website. And then Galen, there's another question from Maria.
Got it. Yes, from Maria. Okay, can we use with all varieties? So the avocado quality meter, 751 Avo, was the model was created with about 95% Haas avocados, and about 5% of the model is with Shepherd. We currently have collaborators working on adding in tropical varieties down at the University of Florida Tropical Research Center. So we will have we will, like I said earlier, we are continuously expanding and improving upon our models. So right now it's mainly for Haas, and it does work for Shepherd, but other varieties they sometimes can work, and then they sometimes, and some varieties might not work as well. It's really kind of a crapshoot, for lack of a better term, with other varieties. So right now the model is optimized for Haas and Shepherd, but soon it will also hopefully include tropical avocado varieties, and as well as other lesser cultivated varieties. Is there any hardware differences between 750 and 751? Oh, sorry. I'm reading to myself, but also out loud. So here we go. Is there, the next question is there any hardware differences between 750 and 751? or just a matter of software with the models that are being inbuilt into the meter? It's a good question. There is a difference between the 750 and 751 hardware. So the reason we decided to even start with building the 751s, besides the fact that it's an easier instrument to use than the 750, as far as you don't have to build a model. The instrument itself is a lot cheaper than the 750, and that's because we use a cheaper spectrometer, and we use other cheaper electrical components inside of it, as opposed to the 750. So if you look at the specifications of this, the wavelength range is only 640 to 110 nanometers. The 750 has a wider spectral range, so it goes down to the 300s. I'm fairly certain, all the way up to 1100 nanometers. So it has more of the visible in there, the visible wavelengths. So we use the 750 to do all of our model building because the components are better. The hardware components are better. But the 751 components are accurate enough and good enough to predict accurately based on the model that we built with the 750. It's just that it's a lot easier to sell an instrument to a harvest operation or a growing operation or a distributor or packer that is at the price point of the 751 versus the 750 is a tougher sell. The 750 also has, as if you attend the webinars coming up, you'll see it's a lot more versatile of an instrument, and it's a lot more loved by the research side of things. So the follow-up question to that is, if we already have a 750, could customer request for the software model of specific fruit from the 751 to be transferred to the 750? Yes. So we do have the models for the 751s, like the mango model and the avocado model, and soon the kiwi model. They're all available or will be available soon. For customers to update the starter models that come on the 750. So we do have the avocado, current avocado model that's on the 751s, which is version 11. That can be put on the 750 and work. It'll work in the same way as it does on the 751. So to answer Darren's question as well, is can models be copied and transferred from the 750 to the 751? It works. It does work that way, but we don't recommend you trying to use models built on your 750 to transfer them onto a 751 that wasn't meant for that
Commodity.
Fruit commodity. That's the word I was looking for. Thank you, Susie. Because these instruments are designed to be single commodity meters. So I guess, Darren, yes, in theory, yes, you can. Yes, in theory and in practice, you absolutely can transfer a model from a 750 to a 751. You would just need to change it to the standard mode, but we don't recommend you do that because the potential then for the customer to accidentally use the wrong model or then not understand or accidentally change a parameter or setting of the spectrometer itself. Things could go wrong, and we also set the spectrometer settings specifically to the model. So it would I guess be like that'd be a good practice for research, and that's kind of what we do for developing our new models is we use the 750, we build it, and then we throw it on a 751, and then we validate it, right? So if you were trying to run your own validation studies on creating a model with the 750 for a commodity that hasn't been tested yet, and then you want to try it on a 751, be my guest. But I would not recommend doing that with our customers, I guess, is what I'm trying to say. Scott is asking about model building. So he says, asks for model building for grapes, for example, with the 750, how long would the process take for a grower of one species? So it's going to take an entire growing season, because what they're going to need to do is have in the model, they want you want to have an equal representation of grapes from every stage of maturity. So you want to have scans of immature grapes, scans and analytical values of immature grapes, and then all the way through the spectrum, all the way to fully mature grapes. Um, and if it's even, I think the species number isn't as much of a factor in this, because even if they're growing 23 different cultivars or 300 different cultivars, they can still, they could still do it all for all the different species in one season. The most important thing is having enough data, collecting enough data to really build a robust model. And we recommend in our 750 manual at least 200 samples. I wouldn't be comfortable putting a model into practice without at least 500 to 1,000 data points. So, but like I said, it will take at least one growing season, because you need that full spectrum of maturity fully represented in your model. You can't just have only mature grapes in your model and then expect it to work well with immature grapes. So hopefully that answers that question for you.
And I'll say too that in the upcoming webinars on October 15th and November 5th, those kind of discussions will go into far deeper for sure.
All right, looks like
Looks
no
like
more questions. So
no more questions.
well, thank you guys so much for
Joining
attending the
us.
webinar. Yeah, hopefully.
And we did record this webinar, so it takes a little while for it to spool, and then for our marketing guy to get it posted. But probably early next week, a recording will be posted, and I will be sending out a link to everybody, so that if you wanted to watch this again, or you wanted somebody else within your company to have the opportunity to watch this, it will be available.
All right. Well, have a great day, everyone. And if you have any further questions, feel free to email me or Susie or Eric, and we'll be happy to answer.
Thanks so much. Have a great day.